Hi everyone, welcome to Byte and Beyond with Uday. In this video, we will learn about one-to-one relationship. First of all, we will get to know what is one-to-one, and by doing practical, we will create one-to-one relationship using Spring Data JPA. So this is the agenda for this video. In this video, we are going to cover these 10 points. Don't worry about these points for now. I'm going to explain all these points with a simple example, so don't worry. So let's jump into our IDE and start creating a one-to-one relationship. But before we do that, let's understand what is one-to-one. So what is one-to-one? So here is an example. Let's understand the example first. So we have employee and we have ID card. So as we know, each employee have one ID card. So over here, this is one-to-one relationship because one employee cannot have multiple ID cards. One employee can have only one ID card, right? So this is why it is one-to-one relationships. So what it says, one employee has exactly one ID card. That is true. And in this video, this is the table design, or this is the entity we are going to create, right? So this is our employee, this is the existing entity, and this is the new entity which we are going to create. So as you can see over here, ID card is the primary key, and this is the foreign key. This is the primary key of our employee entity. So these two tables are connected with this foreign key, employee ID. So that is what we are going to achieve in this video. So let's dive into the practical. Let's create a ID card entity first. So as you can see, we already have employee. We will require some minor changes in this entity. That is it. And before we do that change, let's first of all create a ID card entity. So entity name is ID card. I'm going to annotate this entity with the at the entity annotation. So Spring Boot can know, or Spring Data JPA can know this is entity. And now I'm going to create few fields over here. The first one is ID. Okay, I'm going as this is the our primary key for the ID card entity. So I have annotated this with the @ID, and then I'm going to use the strategy. So I'm going to use over here generation type. Actually, we need generation type as identity over here. Okay. So we can keep auto. We can keep auto, but currently JPA is creating an extra table to generate an ID. So that's I want to avoid. That is why I'm keeping this identity. But let me keep this as you know auto only. I will show you the problem, and then we will change back to the identity strategy type or generation type. So why I have annotated this annotation, because this is the primary key I'm indicating, and this is the strategy. Using that strategy, I'm going to, or the DB is going to create a primary key. Now, let's create a few more fields, such as card number at the red column. I'm going to use at the red column annotation. Length will be 50 and uniqueness is true. Okay. You know about this, right? So this is card number field. I want this card number to, it cannot be null. The length of this column will be 50 and this column must be unique. Okay. So card number basically should be unique. Then let me create one more field. Look, I'm going to use local date for issue date. Okay. When I have issued this, what I can say, this ID card, I'm going to mark this as nullable false because I don't want this card to be, this field to be null. Same goes for the expiry date as well. Okay. Um, this is good. Okay. And let me create getter and setter. Okay. So as you can see, this is the typical entity. Still, there is no connection between ID card and employee entity because we haven't done yet. So before I do that, I would like to explain what is the problem with auto. Okay. So let me start my application. Make sure your MySQL server is up and running. In my case, it is up and running. Okay. And let me drop this schema. Let me drop schema because I want to create new one. Yeah, I think it will create a new schema at the startup. Okay, that's what we need for now. So let me start my application. So till now there is no connection between you know employee and ID card entity. Those are the simple entity. So let me refresh this schema section and let me show you the tables. So see, by default, if I set the strategy, the the generation type, okay, for the both, the generation type, okay, so the generation type is auto. So that is why automatically the JPA or Hibernate is selecting the strategy as sequence, but sequence doesn't work properly or out of the box for the MySQL. So in order to make the sequence work, MySQL needs to create this separate table in order to generate a new primary key. So this we need to avoid. We should not have, additional table to just because we want to generate a primary key automatically. So for MySQL, best strategy is identity. So if I select identity for both for both employee and ID card, then this we won't see this additional tables just to maintain or just to generate the primary key. So I have changed the strategy for both entity, employee and ID card. And now let me restart. So our existing schema will be dropped. Okay. Looks like it is not picking our latest changes. Let me do one thing. let me, let me rebuild my project using this command ambient clean package, and I want to skip test cases. Okay, now let me restart again. So I will see few changes over here. You can see the existing table has been dropped, employee and ID card, and new table has been created. And now if I refresh the schema, let me refresh it from here. Okay. And let me refresh these tables, refresh all. Yeah. But one thing with this approach, what we can do, we can, yeah, even though this employee sequence are not being used, but it is still there. So for that, what I can do, I can drop this schema from here. Let me drop this schema. So those table will be vanished, and we will create new tables as well as schema. Okay. So if I refresh this, yes, new schema is there, and see, now we can see only two tables, employee and ID card. So that's what we need, right? Okay, perfect. Now the actual thing comes. Okay, and now our two entity is ready. This ID card and this employee. Now I want to create connection between these two entity. So that's what we are going to do to achieve or to create one-to-one relationship. Okay, but before we do that, let me change this field name to ID only, because if we use the property name or variable name as employee ID, it doesn't make sense, because we are already inside the employee entity. So we know that this is the employee ID only, so I don't need to explicitly mention that this is employee ID. So keep it short. For this I need to update few update a parameter and few methods, getter and setter. So let me do that as well. Perfect. Okay, great. And okay, now let me stop my application in the meantime. And now let's work on the actual part where we are going to connect ID card and employee entity. So if you can see over here, till now we have covered 2 points. What is one to one? And we have created two tables. Okay, employee and ID card. I mean entity and table, employee and ID card. This both entity and tables are ready. Okay. Now we are going to create relationship between these two tables, so we can have one-to-one relationship. So let's do that. So in ID card, let me mention a new field, which is employee. Okay. Uh-huh. Let me undo this. Okay. Okay. Entity attribute is not marked with annotation. Okay, we will do that. So this is our one-to-one relationship. What? So I am annotating this with the at the one-to-one, and I'm going to declare the fetch strategy or fetch type. So fetch type should be lazy. Don't worry about this. Let me finish this snippet and I will explain you what exactly it is, right? And let me create an at the join column. Okay, name the join column. I will also explain what is join column. Okay, This is employee ID. It should not be null. It must be unique. Perfect. So yeah, our so now we have created one relationship between employee and ID card. Okay. I need to make small changes in the employee class as well. So let me do that as well. Okay. So I will explain everything all together. So let me change the employee. So what I am going to do, I am going to declare ID card over here, and I'm going to you annotate with this at that one to one, and I'm going to add all of this map by employee, cascade type all, fetch type um fetch type lazy, and let I don't need this for now. Let me use the orphan removal instead. Um, orphan removal tree. Okay. So you are might thinking, oh man, no, these are a lot of properties or a lot of options which we have declared inside this annotation at the one-to-one annotation. What does it mean? So let's understand this. So let me go to the ID card first, okay? Because this is quite simple, and let's start with the simple. So as you can see, at that one-to-one annotation. So meaning there is relationship between employee and ID card. There is one-to-one relationship between employee and ID card. That is why I am using one-to-one. Okay. And then we have fetch type dot lazy, right? So what does it mean? Fetch type dot lazy. So it means that when I fetch ID card, employee should not get fetch automatically from the database. Meaning, let's say I am from my API, I'm getting or I'm fetching the ID card. And I want to make sure that when I fetch the ID card, the employee should not get fetch from the database until I ask for employee. So that is why it is fetch type dot lazy is declared over here. Okay. So let me go to my what I can say yeah, this section, lazy versus eager. So there are two types, versus lazy and eager. So lazy, which we are currently using. So what lazy meaning? Both side are as configured fetch type dot lazy. That is true. Okay. So if you see this this points, ID card loads without employee initially. That is right. So when I get the ID card, this employee entity does not load from the database. We will have only ID card. And when we say get employee, that then only we will get this employee entity from the database. So that's what it means. And in case of eager, let's say my fetch type is eager. Okay, my fetch type is eager. So in that case, when I get the ID card, at the same time it loads the employee entity as well. So why we need to use lazy? Because if we do, if we use the eager, every time I get the ID card, it will fetch the employee detail as well. And this is not right because it will have some impact on the performance because now we are fetching two entities, the ID card and the employee, and user might not need both the entity at the same time. Let's say uh, user only needs ID card and we are sending two entities employee, so employee is the unused and unrelevant for the user, and but still with the eager we are loading the employee, so it will have some impact on our performance as well. user. Now, for example, if user is able to get the ID card in 1 second, with the employee, it might get the ID card with 2 seconds, because along with the ID card, now system needs to fetch the employee detail as well. So there is additional 1 second burden on the performance. So that is why we should use lazy. Meaning, when user asks for ID card, it will only get ID card. When user say get employee, when we say over here, just a moment, let me create a getter and setter for the employee. When we say get employee, then only our system will fetch the employee details. Okay, otherwise it won't fetch the employee details. So that is why it is fetched. That is why the fetch type is lazy. Okay. Now you might see this at the rate join column annotation. So what is it about? So this at the rate join column basically means that I want to create employee ID column inside this ID card table. Okay, so let me go to the our PowerPoint presentation. So if you can see in ID card table, we have this employee ID. This is the foreign key, right? Why this is foreign? Why I call this column as a foreign key? Because this is a reference of employees table primary key. So that is why I call this foreign key, and we are using this foreign key employee ID foreign key inside this ID card to connect these two tables, employee and ID card. So in our case, I am saying at the rate join column, meaning this annotation help us to create this employee ID column inside this ID card table. Okay, over here. So that is why I am adding at the rate join column annotation over here inside the ID card table. So it will help us to create employee ID column inside this ID card table. So that is the main purpose. And over here, I am saying that it cannot be null, and it must be unique, because as we know that each employee can have only one ID card. So that is why it must be unique. You can see this is unique. So this is the main purpose to have at the join column annotation. Okay, now let me go to our GitHub. Hmm. So you can see this is foreign key. This is foreign key details over here. So our fifth number is also clear. Now we have covered these two annotation from the ID card side. That's great. Now understand from the employee side as well. So over here we are using one to one as well. Okay, and over here I am saying map by employee, meaning the relationship is handled by the ID card or owned by the ID card entity. So that's what I am saying here. I will explain you what does it mean. Okay, so let me explain that before I move ahead. So this is map by. Okay, so this is map by. Okay, and map by tells JPA do not create another foreign key column on employee table. The relationship is controlled by ID card employee. Meaning, if I say map by employee, it means that ID card is owning the relationship. ID card is owning the control, because ID card is having this employee ID column, not the employee entity. Okay. So if I remove this, JPA will create another column inside this employee table. So if we see the employee representation, okay, we have only these columns in the employee table. But if we remove this, we will have another column as well, meaning another foreign key for the ID card. So that's what we don't need. That's That's what we want to avoid, right? So let me do one thing. Let me drop my database here and let's drop this. And I will show you the example, practical example. So let me restart this application. Okay. Okay. Don't worry about this. The what I can say. This errors. It is basically because of the this DDL auto create. Okay. So don't worry about it. It is basically trying to drop all these tables. But as you know, we have manually dropped the schema itself or database itself. So it is not able to find these two tables, employee and ID card. So that is why we are seeing this error. So don't worry about this. So let me refresh the schema and quickly go to the tables. Or simply what I can do, just a moment. You bring perfect. Okay. So if you see currently this employee have only these columns: salary, ID, email, first name and last name. And our ID card have these columns: expiry date, issue date, employee ID. Okay, this is foreign key, and the ID column, this is primary key and card number. That's what we need, right? As per our presentation, that's what we need. So even if you see over here, let me show you the columns, or you can see um, employee ID. This is the employee ID. If you see over here, our employee ID is the foreign key, right? This is foreign key, and we have this many columns, right? We can see the same over here as well. For now, our foreign key is inside the ID card table. As I explained, if I remove, let me minimize this. If I remove this map by, okay, the JPA will create another column inside the employee table as well. Okay. So let me restart my application and see. Okay. So let's move to the, you know, MySQL workbench and let's execute these statements. So there is no impact on the ID card. That is right because we have made changes in the employee, and you can see we have this foreign key, ID card ID foreign key. So if I refresh this, let me refresh this tables instead. Refresh all, and if I go to employee and if I expand this, you can see ID card ID is the foreign key. This is the primary key of the ID card table. Okay, so that is why it is foreign key. So if I don't mention this map by, it will create another foreign key inside the employee table because JPA won't know that there is a existing uh, foreign key available inside the ID card. So to indicate or to inform JPA, we should use this map by. Okay. So I'm telling JPA, hey JPA, I have create I have created this foreign key inside the ID card table. So please do not create a new one. Okay. So that's what I'm telling over here. And the map by is a inverse side, and the ID card is a owning side. So if I go to our, so over here, let's understand what is owning versus inverse. So ID card is the owning side because it contains at the red join column. That is true. ID card contains at the red join column, meaning it is a owning side. Owning side meaning it owns or it contains the employee ID foreign key. So that is why it is owning side. So whichever entity has at the red join column annotation, it is a owning side. Okay. And employee is the inverse side because it uses mappedBy. So employee here, the employee entity is a inverse side, right? So our owning versus inverse is clear. And you are might thinking that why we have added this at the red join column inside ID card only. Why we haven't added this at the red join column annotation inside the employee? The reason is simple. The reason is simple. As we know that employee can exist without ID card, right? Employee can exist without ID card, but ID card cannot exist without an employee. Because if I have, let's say, ID card 123, but there is no employee for this ID card, so there is no meaning of uh, having existing of that ID card, right? So ID card cannot exist without employee. That is why we have added ID card, this at the rate join column annotation inside the ID card table or ID card entity. Because in order to have ID card, we must have an employee first. So that is why this at the rate join column make more sense on the ID card table than on employee table. Because ID card cannot exist without an employee, but employee can exist without ID card. That is true. So that is why that is why it make more sense to have at the red join column annotation inside the ID card table. Okay. Now let's understand few more properties such as cascade type all. Okay. So this is the advanced topic, but still I will going to explain the high level what exactly it means, right? So all meaning it contains multiple properties. Okay. You can see detach, merge, persist, refresh, remove. So if I say all, it will it will apply all this property: detach, merge, persist, refresh, and remove. Okay. So what does it mean basically? So let me go to the our points. So our owning versus inverse is complete. Map by also complete. Okay. Map by meaning do not create another foreign key column on employee, right? The relationship is controlled by the ID card table. Okay. Our foreign key is also clear, but we will talk about that later. Let's finish this cascade. Okay. So cascade dot all. Okay. Detach, merge, persist, refresh, and remove. All meaning it will apply all of this. So what does it mean? So cascade type meaning on employee side, because this is the, as I explained, employee can exist without ID card, but ID card cannot exist without employee. So that is why we have added this cascade type on the employee side. And the effect, what is the effect of this cascade type? So the effect is, if we save employee, ID card also gets saved, or if we persist the employee, ID card also should persisted. And if we remove the employee, the ID card should also get removed. So this is the main purpose of having this cascade properties, right? So if I go to this, so if I persist meaning save. If I save the employee, the ID card should get saved automatically. If I remove the employee, ID card should get removed automatically from the database or from the table. So that is the main agenda. Same goes for the detach, merge, and refresh. If I detach, merge, or refresh this employee entity, ID card should also get detach, merge, or refresh. Meaning, whatever effect I am applying on employee entity table, the same effect should apply on the ID card table as well. So that is what I am saying over here using all. Okay, then comes orphan removal. Okay, so what is orphan removal? Orphan meaning there is no parent. Okay, orphan meaning there is no parent. So over here, if we see clearly, employee is a parent because employee can exist without ID card, and ID card is a child because ID card cannot exist without employee. Same goes for the real world example. I mean, we all have our parents, right? And parents can exist without us, without children, right? But as us, we cannot. The children cannot exist without parent, right? So, orphan removal is for this. So if I say, if I say orphan removal is equal to true. So if I say employee set ID card is equal to null, then ID card will automatically get removed from the ID card table. Meaning, when I say employee dot set ID card null, meaning I don't have this employee is saying I don't have any ID card, and this ID card will automatically removed from the table or automatically deleted from the table. So that's what it means. By orphan removal is equal to true. By setting ID card as null, the particular ID card will be deleted from the table. Okay. Then we have fetch type lazy. We have already explained this. Okay. So yeah, that is how you can create a one-to-one relationship. And now it's time to insert few SQL statements in the table, and we will see how exactly this data get inserted, and we will fire few select statements to get the details from the tables. So before we do that, let's understand all these points. Let's summarize all these points. Okay, one by one. What is one to one? A one to one relationship means one row in table A is linked to exactly one row in table B. Okay, we will see that with the example. Don't worry about this. So one employee has one ID card, right? And one ID card belongs to one employee. So it is one to one relationship. We have already seen the database design employee in ID card. So this is our employee in ID card database design. Then we have understood owning versus inverse. So whoever table has at the join column, it is owning, and whoever table has this map by, okay, map by property, it is inverse side. And what does it mean by at the red map by? It means do not create another foreign key column on employee. We have seen that by removing this map by employee, the system has created the additional foreign key inside the employee table. Okay, so that is why we need to use map by the foreign key. Okay, the foreign key we have seen in this case. This is foreign key. Employee ID is the foreign key. ID card dot employee ID. Okay, this reference to the employee ID, meaning this employee ID reference to this primary key of the employee table. Okay, and this ensure each ID card is tied to exactly one employee, meaning this not null plus uniqueness. You can see over here nullable false and unique true, meaning each employee should have one ID card. Then we understood cascade, right? Then we understood the orphan removal as well. Then we understood lazy versus eager, right? but this is for the you can go through this readme file after, even after this video. So that is why I have created these points for you, so you can refer it right after this video, so you can memorize everything, or you can understand all the concept very well. Now our practical part comes. Okay, now let me restart, or first of all let me delete this schema, because we did some experiment with the map by property, right? So let me create a new schema, a fresh schema. So let's restart. Okay, great. Don't worry about this this field. So if I change this field to update, basically it is on startup, it is trying to delete those id card and employee table, as those id card and employee table is not exist. That is why we seeing those error while starting our application. But with the update, we won't see such errors. See, those errors are gone now. Um, okay, okay. Still this update hasn't get affected. I need to clean and build, but that is not required for now. Let's jump to the practical. So let me copy this, and yeah, over here itself. Let me use, or let me select this schema as default. Set default schema, and let me go to the new SQL file. Okay, your database name. Okay. I don't need this because we have already selected. But yeah, even if it is there, you can say Spring Boot Practical. This is the database name basically. Let me execute. So you can see these are the columns available over here. But I prefer the visual effect. So let's see the visual effect. So if I see information, if I click on this, I can see this many columns: salary, ID, email, first name, last name. These are the indexes. Okay, two indexes. And if I expand this, okay, and there is no foreign key inside this table, employee table. And if we see the ID card table over here, these are the columns: expiry date. Let me close this one so you don't get distracted. Expiry date, issue date, employee ID. This is the foreign key. Okay, this is the primary key. This is the card number. Okay. So you can see primary key is our ID column. Over here, employee ID is unique because we have mentioned over here nullable false, unique is true. Okay. Then card number is also unique, right? Because we have mentioned unique is true, right? And then foreign keys come. Employee ID is the foreign key. So this is our table structure. And over here, inside the SRC main resource SQL, this path I have created a few SQL statements. So let's go to those SQL statements. Okay. Let me go to the GitHub over here, and as you can see, let me expand this SRC main resources SQL. Let me expand this. As we know that this ID card cannot exist without employee, so we are creating or inserting employee first. So let me do that. Let me fire the select statement as well. You can see the tables are empty now. but let me insert, let me execute all of this statement, and let me, so there is no ID card, okay, for this employees, but yeah, we can see few employees over here: John Miller, Emma Wilson, Lam Anderson. Okay, these are three employees, and for these employees, we need to have ID card. So for this ID card, we have this insert statement. So copy this from here, and let me insert those in SQL statement as well. Okay. Now if I refresh, you can see now we have employee as well as ID card, and you can relate. We have over here uh, ID employee ID 1, 2, and 3. And if I go to ID card, okay, this ID card is belong to employee number 1. This one for the employee number 2. This one for the employee number 3. Right? Now it is matching our design over here. You can see employee ID card, and this is the our foreign key. This is our foreign key. Now let's try to fetch data. Okay. So let me go to the README, and by firing this query, you can get the employee as well as ID card information. So let me do that. You can see this is employee John, okay, and John Miller, and this is the employee ID. This is the card number, basically ID card detail. This is right. 1001, 1002 for Emma Wilson, 1003 for Liam Anderson. So that's how, guys, that's how we can build one-to-one relationship between employee and ID card. I hope you have learned lots of things today. You have learned about one-to-one relationship, how we can create one, and in the next video we will create REST APIs, and via REST APIs we will try to persist this employee and ID card details, and in those video as well we will learn about orphan removal and cascade type with the practical example. So see you in the next video. Bye.